Welcome to Section 4, Lesson 1. Here we're going to be determining unknown measurements. So in this video we're going to be looking at some examples. We are already given the surface area and you had to find an unknown dimension like the height or the radius. So let's have a look. Example 1 says a right square pyramid has a surface area of 261 square feet. If the lateral area is 180 square feet, what is the length of the base? So let me start by drawing a right square pyramid. Now we're looking for the length of the base. So I can label each side with X, seeing that it is a square. Now what is the lateral area? Now the lateral area is the area of the sides of a figure, so it doesn't include the base. So in this example with the square pyramid, the area of the four triangles is a total of 180. So now if we look at the surface area of this pyramid as being the area of the base plus the area of all the sides, we can now fill in what we know. We know the surface area is 261, so we can put that on the left side of the equation. The area of the base is a square, which is just x times x, so I can write that as x squared. And then the area of the sides is the lateral area, which we're told is 180. So now we just need to solve this equation for x. And to do that, you always want to isolate x. So I will start by bringing positive 180 over to the left-hand side, making it 261 minus 180. Now when I subtract those, I get 81 equals x squared. Now to solve for x, I need to find the square root of both sides, which means x would equal the square root of 81. And when I simplify that, we get an x value of 9. So now we can say that the length of the base is 9 feet. Now for example 2. CJ covered the stacking toy below with 636.2 square centimeters of wrapping paper. If the radius is 7.5 centimeters, what is the slant height of the right cone? So let's remember what the formula for surface area of a cone is. That is pi r squared plus pi rs. So now let's fill in what we know. The surface area is 636.2, so I'll put that on the left side of the equation, and I'll fill in my r with 7.5. So I would get this here. Now to solve for s, let's simplify what we can. Let's put pi times 7.5 squared in the calculator to give us 176.7. And let's also multiply pi with 7.5 to give us 23.6s. Now to solve for s, I'm going to start by bringing the 176.7 over to the left-hand side and subtract that from 636.2. So when I work that out, I get 459.5 equals 23.6s. Now to solve for s, we need to divide both sides of the equation by 23.6. And when I do that, I get an s value of 19.5. So that means the slant height of the stacking toy is 19.5 centimeters. Now for this last example, once again we have a right square pyramid and we're told that it has a surface area of 61.25 square inches. If the length of the base is 3.5 inches, what is the slant height? So here's our diagram of a right square pyramid with a base length of 3.5 inches. We are looking for the slant height right here. So similar to the first example, we can look at surface area as being the area of the base plus the area of the sides. So let's fill in the surface area to be 61.25. The base would be 3.5 times 3.5. And we can write the area of the sides as 4 times the base, 3.5, times the slant height, divided by 2. Now let's simplify this by multiplying 3.5 times 3.5 to give us 12.25. And then 4 times 3.5 divided by 2 is where the 7 comes from. Now to solve for s, let's bring 12.25 over to the left and subtract that from 61.25, leaving us with 49 equals 7s. Now we need to divide both sides by 7, which means that s equals 7. So now we can write that the slant height of the square pyramid is 7 inches. So that concludes the section of surface area of right cones and right pyramids. You can now move on to the next activity in this lesson.